Okay, hello everyone. So today we are going to start with the compiler design subject. So this is the first lecture in which we are going to study why to use the compiler, what is compiler, and what are the phases of the compiler, right? So first of all, we'll start with system software, right? So there are two types of software we use in the computer system. One is the system software and another is the application software, right? Another category is application software. So whenever you want to work with the computer, you have to use these softwares. So first of all, what is system software? It is a most important part of the computer. Whenever you purchase any computer, you get the system software with that. Without system software, you can't work with the computer, right? Now, what are the system softwares? So basically, system softwares can be one of the most important system software that you have already studied is operating system, right? So first of all, when you purchase the computer, you have to install the operating system, then your computer will be able to work on that, right? You will be able to work on that computer. So you require a operating system. It can be Windows, it can be Linux, it can be Fedora, it can be Red Hat, any version of the Linux. Mac, if you have purchased Apple, then you have to install Mac operating system, right? So different type of operating systems you have in the market, and according to the architecture of the computer, you have to install the operating system, right? Now, the second category of the system software is called as firmware. It is also called as bootstrap loader. Bootstrap loader. Now, what is this software? This software is basically a system software which is responsible to load your operating system from hard disk to the primary memory. And what is your primary memory? Your primary memory is RAM. Workable memory is RAM, right? So this software is required because whenever you install the operating system, your operating system stores into the hard disk, right? And when you switch on the computer next time, you require the operating system to be loaded into the RAM, then only you will be able to work with the computer. So firmware is basically a software, or you can call it bootstrap loader, is a software which loads your operating system from the hard disk, from the boot sector. You know that there are various kind of sectors in your hard disk, right? So there is a first sector or zero sector that is called as boot sector. So it starts loading uh, your operating system from boot sector to the RAM, right? So this is the second system software. Now the next system software is translators. Now basically there are three types of translator that we generally have as a system software. So one is a compiler, another is interpreter, and last is assembler, right? So compiler is basically, first of all, translator. What is the work of translator? To convert one language into the another language. I mean, whatever type of translator is it, if it is a converter, it is a language converter, then it will convert your English language into Hindi language, or Hindi language into English language, or some other language. So in the similar way, your computer has a translator. There are three types of translator it has: compiler, interpreter, and assembler. So compiler is basically a translator which converts the high level language into the low level language as a whole, which means the whole program will be converted into the low level language. While in case of interpreter, it does the same work, like it converts the high level language into the low level language, but your program will be converted line wise. Like first it will convert the first line, then second line, then third line, and then so on, right? Now come to the assembler. Assembler is basically a special kind of translator which converts your low level language into the machine language, right? So there are three types of language used by your computer: high level language, low level language, and machine level language. So high level language is a language which is used generally by the programmer, you and me, right? User, programmer, you and me. So this is high level language. It is a similar kind of English language. Fine. Now the low level language is basically an intermediate language, which is neither a high level language nor it is in the form of 0 1. It is not in the form of binary. So it is basically in the form of codes. You need to understand what is the functionality of a particular code, then only you will be able to use that particular language. So basically, if you study microprocessor subject as a course in the computer science or information technology, for example, microprocessor 8085, then you'll come to know how to program the microprocessor 8085. There are certain codes to write the program or to write the code into the microprocessor 8085 or 8086 or any kind of microprocessor. If you are using for the programming, then you have to use assembly level language program, right? Assembly level language. Now the third language is a machine language, which is used by or understandable by machine. That is in the form of 0 and 1. So translator, compiler will convert your high level language program into the machine level language program as a whole. Interpreter will convert your high level language program into the machine level language program, but line by line. And assembler will convert low level language program into the machine level language program. So this is the translator. This is all about the translator. So in this particular lecture, we'll focus on the compiler. We'll discuss about compiler and assembler both, and sometimes we'll discuss about the interpreter also at the initial stage. So before starting the compiler design in a depth, let's discuss about the difference between the compiler and interpreter, like compiler versus interpreter, right? So what is the first difference or advantages or disadvantages between of compiler and interpreter? The first difference we'll take from the definition. The compiler will convert your high level language program into low level language program as a whole, while your interpreter will convert your program line by line. Fine. So what will happen according to the first difference? When your program is converted as a whole to the low level language, so obviously your speed will be fast. It is a second difference. So first is the difference of the conversion. Second is the difference of the speed. Obviously your compiler will be faster in comparison to the interpreter because it is converting your program as a whole, and interpreter is converting your program line by line. But in case of compiler, all the errors, if there is any if there is any error occur in your program, you will get all the errors at the end of the compilation process, and these errors now you need to search into the source language program. Where is this error, right? Generally what happens, the line number is mentioned with the error, but sometime the error doesn't exist on that line. So you have to search, or you have to understand what type of error is it and where is this error is possible. Obviously this error will be there either above the line or below the line. So you have to search for that. But in case of interpreter, your debugging is quite easy. Your error finding is quite easy. Why? Because your interpreter converts your one line of the program at a time, right? So if there is any error in the line, it won't move ahead. So which means whatever error you are getting, it is because of that line only. So you have to debug that line. So it is more easy to find the errors or to debug the errors in case of interpreter. So error handling is quite easy in case of interpreter. Now, there is a fourth difference. Basically, your compiler creates the object code, and from that object code, it creates the exe file, executable code. Now, whenever you want to give the input and you want to see the output, you need not to compile program again and again if it is error free. If it is once it has been compiled successfully and run successfully, it has created the executable file. Then for the next time, if you wish to give some input and want to see some output, you need not to go for the whole compilation process. right? Because it once it has created a executable file in the form of exe, or in case of Linux, a.out file is created, then you have to run only that exe file or a.out file. It will automatically ask for the input and will give you output. So you need not to go through for the whole compilation process. While in case of interpreter, you have to go through for the interpretation process again and again. You have to run your program again. The interpreter will again run your program, convert your program line wise, and then it will execute your program, right? So the compiler will create object file, and after that exe file, executable file, right? While in case of interpreter, you don't get these kind of files. So you have to go through with the translation again and again if you wish to provide the input and you want to see the output, what kind of output you will get after the interpretation, right? So these are the main differences between compiler and interpreter. For other difference, you can refer the book. Fine. So we have seen that there are three types of translator, and the main differences between compiler and interpreter we have already seen in this lecture. So now I'm going to start with the compiler. So if I draw the diagram of the compiler, or a block diagram of the compiler, so what is compiler? Compiler will take source code as a input and will provide you target code as the output, right? So what you will provide in the input? You will provide the source code as a input, and you will obviously get target code as a output. Fine. And this is your compiler. This is your compiler. Okay. But when we talk about the compiler, suppose let's take one example. We talk about the Turbo C, we talk about the Dev C++, we talk about the GCC compiler in Linux. So there are various softwares embedded with the compiler as well. Compiler is not only the software which is there with Turbo C or GCC or Dev C++. There are various supporting software used by the compiler. So we'll see the whole diagram, the whole supporting software with the compiler. What are the software we use with the compiler and what are the functions of these softwares, right? So, okay. So let's draw the diagram first. So we have first software that is called as preprocessor. That is called as preprocessor. Okay. Now we'll talk about the next software. Okay. So the next software is a compiler. First, I'm drawing all the boxes. After that, I'll write. And after compiler, the supporting software is assembler. And after assembler, the supporting software is linker and loader, right? So we have a preprocessor, then we have compiler, then we have assembler, and then we have linker and loader, right? Now let's see what are the inputs we generally provide to these softwares, right? So first, the high level language source code will be given to the preprocessor. Okay? Now, after preprocessor, the preprocessor, क्या होता है इसको हम will discuss in the detail. After preprocessor, you will get pure high level language. Pure high level language, right? Now, this pure high level language will behave as an input for the compiler, and this will generate the assembly language code. So basically, we can call it low level language code, So low level language, right? Will be generated, code will be generated by the compiler. And obviously this code will go as an input to the assembler, and the assembler will generate the machine code. And this machine code will be relocatable machine code. Fine. So the assembler will generate machine code which can be relocatable, which can be relocate to in the RAM anywhere. Fine. And finally, the target code, that is the executable code, will be generated by the linker and loader at the end, right? So after relocation of the after relocation of the machine code into the RAM, that code will be that converted into the executable code after linking of all the libraries, functions, etc. in the source code. Finally, you will get the executable code. And whenever you want to see if the input is different, what should be the output, you need not to go through this process again and again. You have to execute only. You have to execute only executable code. It will simply ask for the input. You will provide the input and it will give you output, right? So first of all, what is preprocessor? Preprocessor is a special type of system software which actually deducts all the macros and preprocessors written in your program and will expend those preprocessors into the source code. Now let's take one example. Suppose you have written a program in C language and you have written, first of all, you write these type of file inclusion code in your program. Now after this, suppose I have written one more code as a preprocessor, define, and I have defined some s, suppose, and the definition is s plus, it is returning s plus s. This is the macro that I have written in the program, and after that my main program starts. Right. Now, what happens in the program when I'm going to compile it? First of all, the preprocessor will deduct all these kind of statements which starts with the hashtag. These statements are called as preprocessor statements, right? And preprocessor is a software which deducts all these type of statements and it converts these statements into the source code. It expends all these statements into the source code in the form of the either library files or in the form of the expansion of the high level language code, right? Similarly, it deducts all the macros written using hash define and converts these or expand these macros into the program. Suppose I have called this function here, right? So what will happen? It is a macro, will be deducted by the preprocessor, fine, and it will go to the definition and it will substitute this definition here. So suppose I have called a function, a macro, in this way, right? So what will happen after the expansion of the macro? This line will become r is equal to 2 plus 2. This is called as macro expansion. And this thing is done by the preprocessor, right? So the preprocessor will convert or expand all the preprocessor statements into the source code, and your source code will become now preprocessor free code. This is called as pure high level language code. तो ये वाला जो कोड है, जो macro expansion के बाद हमें मिला है, this is called as pure high level language code, जिसमें कोई भी आपका प्रीप्रोसेसर स्टेटमेंट एग्जिस्ट नहीं करेगा. वो सारे के सारे स्टेटमेंट्स क्या हो चुके होंगे? एक्सपेंड हो चुके होंगे, राइट? सो दिस प्योर हाई लेवल लैंग्वेज विल बिकम द इनपुट फॉर द कंपाइलर. नाउ कंपाइलर विल कन्वर्ट this high level language code into the low level language code, and obviously it is in the form of assembly language, so it will be machine dependent, because the language, the assembly language depends on the processor architecture. Whatever is the architecture of the processor, your code will vary according to that. So the compiler will convert pure high level language into the low level language. This low level language will be then translated by the assembler, will go to the input for the assembler, will be translated by the assembler, and the assembler will generate the machine code, right? Now this machine code is generally relocatable machine code. Relocatable का मतलब मैंने आपको क्या बताया कि जो इसका एड्रेस है वो रैम में चेंज करके आप इसको किसी भी जगह पर अलोकेट कर सकते हैं. इसका ऑपरेटिंग सिस्टम कहीं भी इसको अलोकेट कर सकता है, नई मेमोरी. ठीक है, तो आफ्टर दैट लिंकर एंड लोडर क्या करेंगे, इसको रीलोकेट करेंगे कहीं पर रैम में. विल एग्जीक्यूट दिस प्रोग्राम by linking all the libraries and all the functions into the source code, whether it is statically or dynamically, that you can study in the Wikipedia or by googling what is the function of linker and loader, right? So after linker and loader functions, function completion, you will get the executable code. The program will be converted into the exe file, and this exe file is a complete file. So whenever you want to check that program again, you have to run only exe file. It will simply ask the input and will give you output according to that, right? So this is the brief description about the parallel software, or you can say that some supporting software that's the compiler uses. Okay, now most important thing, whenever you write a program in a software, for example आप turbo c पर कोई c language का program लिख रहे हैं, या c++ का program लिख रहे हैं, या आप dev c use कर रहे हैं, या फिर आप linux में gcc compiler use कर रहे हैं. So basically all the software has these supporting softwares inbuilt into it, right? But when we talk about the compiler, so compilers is only this. It takes pure high level language, it provides low level language. But when we talk about the GCC compiler or Turbo C, so it has preprocessor, it has assembler, it has linker and loader inbuilt into it. Fine. So whenever you give the program of high level language, it automatically gives you executable code at the end, and we say that it is a compilation process. But actually compiler takes only pure high level language and it provides low level language, right? So in the lecture series we will focus only on the compiler. We are not going to cover preprocessor, assembler, linker and loader. That you have already studied in the operating system subject, operating system course. So we'll focus only on the compiler. What are the phases of the compiler, how these phases works, and how your pure high level language program converts into the target code, that is the low level language program, right? So let's start the block diagram of the compiler now. Fine. Okay, so first phase of the compiler is the lexical analyzer. Then the next phase of the compiler is syntax analyzer. The next phase of compiler is semantic analyzer. The next phase of compiler is intermediate code generation. The next phase of compiler is code optimization. And the last phase of compiler is target code generation. Fine. So these are the phases. High level language is provided as the input to the lexical analysis. Then the output of lexical analysis goes to the syntax analysis. Output of the syntax analysis goes to the semantic analysis. Output of the semantic analysis goes to the intermediate code generation. Then code optimization. Then we have target code generation. And finally, you get the target code, right? Okay. So input is high level language program. Fine. Where we are giving this input? We are giving this input to the first phase of compiler, that is lexical analyzer. Right? So first phase is lexical analyzer. Then we have next phase, that is called as syntax analyzer. Okay. Now what is the output generated from the lexical analyzer is the tokens generated by the lexical analyzer, and it goes to the input for the syntax analyzer. Now the next phase of compiler is semantic analyzer. Right? What is generated by the syntax analyzer? The syntax analyzer generates the parse tree. And it goes to the input for the semantic analyzer. Now the output of the semantic analyzer is semantically का मतलब meaningful verified parse tree. हर एक स्टेटमेंट का क्या करेगा, ये मीनिंग जो है वो एड ऑन करेगा पार्स ट्री में, और उसके बाद जो पार्स ट्री जनरेट होगा दैट इज कॉल्ड एज सीमेंटिकली वेरीफाइड पार्स ट्री. नाउ द नेक्स्ट फेज इज intermediate code generation. Okay, now the output of this intermediate code generation is generally 3 address code, although there are various types of intermediate code generations, generation method, but the most popular method is a 3 code method. So we'll study 3 code method in detail. Right, now the next phase is code optimization. Okay, so basically the purpose of code optimization phase is to reduce the size of the program, to reduce the size of the code, source code. Right? So what is the output? Optimized code you will get as a output. And after that we have target code generation phase, and this particular phase will provide you final code, that is target code, in the low level language. Right? So this is basically a phase diagram of the compiler. Now most importantly, with all phases there are 2 parallel phases, there are 2 parallel things which runs. So one is symbol table and another is error handler. One is symbol table and another phase is error handler. Right? And these phases are connected with the all phases. So symbol table is connected with lexical analyze, syntax analyzer, then it is connected with semantic analyzer, then it is connected with intermediate code generation, then it is connected with code optimization, then it is connected with the target code generation. Right? In the similar way, error handler is connected with the lexical analysis, then it is connected with the syntax analyzer, then it is connected with the semantic analyzer, then it is connected with the intermediate code generation, then it is connected with the code optimization, then it is connected with the target code generation. Okay, so basically now let's summarize the phase diagram of the compiler. So basically how many phases are there? There are 1, 2, 3, 4, 5, 6. 6 phases are there in the compiler. The first phase of the compiler is lexical analyzer, which takes the pure high level language as the input and it provides the tokens of the as a output. Right? These tokens goes as a input to the syntax analyzer, and the syntax analyzer verifies these tokens by using the grammar, and it provides the parse tree. Right? syntax parse tree or syntax tree. We can call it syntax tree also. This parse tree goes as an input to the semantic analyzer. The semantic analyzer will add the meaning to the, or will cross verify the meaning of the statement or expression, and will generate the semantically verified parse tree, right? And after that, the semantically verified parse tree goes as an input to the intermediate code generator, and the intermediate code generator that converts the code into the 3 address code. What is the meaning of 3 address code? That maximum you will have only 3 operand in the expression, right? After that, this 3 address code will go as an input to the code optimization, and the code optimization will try to reduce to the size of the code by using various kind of techniques. And at last, we have the target code generation, which converts your, or which generates the target code, that is the low level language code, from the optimized code, right? Apart from that, we have 2 parallel blocks with the phase diagram. One is the symbol table, where all the symbols like identifiers, keywords, everything is stored into the, whatever you have used as a word in the program will be stored in the symbol table. And the error handler is a block which stores all the errors generated in the process of the compilation, is stored into the error handler, right? So this is all about the block diagram of the compiler. Now we'll see in the next lecture, we'll see, start with the lexical analyzer, and after that we'll see all the phases one by one in the next series of lectures, right? Okay. So I'm ending my lecture here only. If you have any questions,